Hey guys, it's Neil here, also known as Dragon Cannon, and today we will be doing a mission to Duna, the Mars analog in Kerbal Space Program. So here we go, we are going to do a low carbon orbit rendezvous mission profile, which means that we are going to launch this, which is our transfer stage. Right now it is Jebediah Kerman on board, however there are room for 3 Kerbonauts. The other 2 will launch with the lander afterwards and join him in orbit, where they will rendezvous and dock. At that point we will transfer out the entire spacecraft out to Duna and go land on Duna. Depending on our fuel situation, maybe we will move on to Ike, Duna's moon, and land there as well, and return to Kerbin. So this will be my first video of an interplanetary mission. However, I have flown to pretty much everybody in the game and landed on all of them, but this will be the first video of doing so. So you guys are part of a very special thing today. This spacecraft right now, we have 6 radial boosters feeding fuel into the middle with that has a mainsail. They're about to be ditched, and we will just be using the mainsail with its full fuel. The next stage, which will do our orbital insertion, has a skipper engine, and there we go. We have a clean separation. And if we have any fuel left in that skipper engine, that will start our interplanetary injection. So we'll see. I've gone ahead and time warped, so we're right at about the correct time for a Duna transfer. So we should get a fairly good encounter with Duna right out of Kerbin's sphere of influence. But first, we need to launch this spacecraft into orbit and bring up the lander and dock with him, which will be happening within the next few minutes. I have not tested either of these spacecraft. However, they should have more than enough fuel to perform the missions that we need them to do. So we are doing a mission to Duna, as I've said, which is the Mars analog. Hopefully pretty soon, in the next maybe 20 years or so, humans will be going to Mars. Of course, we could have gone to Mars many years ago. Don't even get me started about that. It makes me very upset that human space flight has not advanced to that by now, which it clearly should have, and we have the capabilities despite what NASA and some of the others will try to tell otherwise. Anybody who wants to learn a little bit more about that, I highly recommend reading some of the works of Robert Zubrin, who is the president of the Mars Society, a foundation of which I am a member, who our number one goal is just humans to Mars. Of course, Mars is a very, very interesting target for exploration, and there are multiple spacecraft exploring Mars as we speak, robotic spacecraft, including the famed Curiosity rover that landed a couple years ago. It's very interesting, the search if maybe there's microbial life on Mars today, and even if not, if Mars ever may have hosted life. And these are really big questions in science today that could really change the way we view the universe and our place within it. So exploration of Mars is really huge for human spaceflight and for science and pretty much anything else. We're going to bring him up to about 150 kilometer orbit. Set up our maneuver for the orbital insertion maneuver here. Yep, that's good enough. Go ahead and get ourselves pointed correctly. So the Robert Zubrin's Mars plan is something that he calls Mars Direct, which is not this kind of a mission profile. In the Mars Direct plan, you would send one spacecraft unmanned to Mars, where it would land, and it would actually mine the surface and use the elements there to produce fuel for a mission home. When that is done, we would then launch another spacecraft that would bring humans and land next to the first one. The humans would go and explore Mars for a while, and when it's time to go home, they would go to the first spacecraft that was there and producing fuel for a couple of years and be able to use it as their vehicle flying home. So here we go, our transfer stage is in orbit. I'm going to go ahead and put these lights on there, illuminating towards the docking port, which will help us to dock the other spacecraft to him. So while he's up there, we'll go. I've already designed and built a lander, so hopefully the rocket will be good enough to get it into orbit, and the lander will be able to land, because if not, that would just be a bummer that we did all this for crashing or landing and not being able to take back off of Duna. But I think we should be good here. Here is our lander. So we will go ahead and set that to launch. Bring it out. The RCS is on the lander so that when we ditch the lander, we're not just carrying for no reason RCS fuel. That was a little bit overdoing it, but that's okay. We can work with that. And 3, 2, 1, liftoff. So we have 6 solid rocket boosters surrounding a very similar launch stage that we had on the other spacecraft, but instead of using liquid-fueled boosters, we are using solids. It is a much lighter payload, so they should be more than enough. I've actually lowered their thrust. Now that we have tweakables in the game, you can lower the thrust on the SRBs, which will make them burn for a longer period of time at a lower thrust level. So normally at full thrust, these burn for about 45 seconds. I expect them to burn for about a minute now with the way I have them set up. See, we're passing 45 seconds and we still have plenty of fuel in them. So here we go. Just keep going up on our launch. We're going to go, it's a little bit ahead of us, the other spacecraft, so we will launch into a slightly lower orbit and then catch up. Because, of course, when you fly in a lower orbit, you are going faster. That is the nature of orbital mechanics. Oh, here we go. We'll do some of a gravity turn here. I'm hoping that this will get into orbit without us having to use the engines on the lander. But even if we do, it's not really a problem. We can work with that. So here we go, and apoapsis is rising, which is good. There we go. Time to ditch that stage. And oh, that's a problem. So, and fire up our skipper engine here, which will get us most of the way, if not all of the rest of the way, to orbit, hopefully. As I've said, I've not tested any of these spacecraft, so you're seeing it as it's happening here. No previews for me. You get to take part in all of the excitement of this mission, which will be quite exciting. My first video of an interplanetary mission. So hopefully everything will go the way that we want it to go, and we will have a successful mission to Duna. Here we have Bill and Bob in the lander. They will go up and meet Jeb, who's already in orbit. Oops. We are actually turning a little bit steeply here, so I'm going to go back up and try to raise our apoapsis some more. We have less thrust on this stage. However, our speed is going up, which is always good. Apoapsis is rising. There we go. Now we can turn some more because... Oh no. That is bad. Okay, well, we're going to have to use the lander stage and its fuel to get the rest of the way to orbit, which is really not good. But we should have plenty of fuel overall for this mission, so I think we'll be okay. We're not going to try to reset up this launch vehicle or launch again. We're going to work with what we got. As we see here, we're staying about 24 seconds away from apoapse, which is a little bit less than I would like, but as long as it doesn't go down, we're good. And the good news is we're getting a lot of horizontal orbital velocity while we're doing this, so we're going to be able to get into orbit, hopefully. Not hopefully, almost definitely. Oh no. That's a real problem on this lander. So you can see the fuel is draining from 3 of these and not 1. It looks like I accidentally only put 1 fuel line instead of using symmetry. So that is not good at all. But it's another thing that we'll have to deal with. We're going to, we're doing this in real time. There was an engineering problem on the spacecraft and we are going to have to compensate. So you can see our spacecraft wants to move a little bit off of its trajectory because of this. So once we cut our engines while we're drifting or we're coasting, I am going to transfer fuel from the center section into the outer tanks that should hopefully deal with this problem. Good news is we are definitely, our time to apoapsis is increasing and we're getting up close to orbital velocity. Bad news is the spacecraft does not want to stay where it's supposed to stay pointed, so we're going to have to compensate for this. Wow. There we go, that's good. 78 for now. We're going to transfer this fuel. We should have plenty to fill up all of the tanks, so that's definitely a plus. Keep ourselves balanced. This lander, of course, has 8 parachutes, which I'm hoping should be enough to bring us most of our descent down to Duna. We may have to fire the engines a little bit to make sure to cushion our landing, but hopefully these 8 parachutes will get most of the work done. There we go, that's our full tank, so that means this one over here is the one that needs fuel. And it is getting fuel. And in the meantime, while that's filling itself up, I'm going to pour myself another drink because, it's always good to drink while you're making a video. I'm actually drinking currently tequila. Why? 1, because I like tequila. And 2, the developers of Kerbal Space Program, Squad, are located in Mexico, so it seems fitting that while I'm playing their game, I'm drinking one of their drinks. So here we go. We're going to just put ourselves into a nice circular orbit down here and then allow ourselves to catch up to the transfer stage. Should only need a small amount of delta V to get into this orbit because it's, we were already going pretty close to orbital velocity there. There we go. Good enough. And in the meantime, I'm actually going to disable fuel from this. I guess it doesn't matter because it's empty. So here we go. Now we just need to warp a little bit to catch up to our other spacecraft. In the meantime, we can talk a little bit more about Mars, which is, of course, a very interesting place. So I'm sure many of you have heard this event that has occurred recently, the Opportunity rover, which has been on Mars for quite a while now, has recently photographed an interesting rock that was not there. Okay, so at this point we should already be firing prograde to set up an encounter. That was not there like a few days before before it was photographed. Like they photographed the exact same spot twice, and once it was not there and once it was. So they have been investigating it. It's very interesting. It looks like a jelly donut, which is just cool. According to NASA, there is not actually a Krispy Kreme location on Mars, which is a bummer. But it has a very different chemical composition than the surrounding rocks. So we're really not sure about it. And it's become somewhat of a controversy because there's a guy who has just recently sued NASA, or he's filed a lawsuit against NASA, saying that it is alive and NASA is refusing to investigate life on Mars. This guy's crazy. This is not true. They have investigated it. They're still investigating it. They aren't really sure what this rock is, how it got there, anything like that. There are a couple of hypotheses, but it is not alive. Of that we're certain. And in addition to that, of course, finding life on Mars is something NASA would love to be able to announce to us. It's not like they're trying to hide that. So it's crazy, this stuff that he's saying. And he also is a known conspiracy theorist in that he has, in the past, he's one of the 9/11 conspiracy theorists. He has been known for finding conspiracies which do not actually exist. So here we go. We're just going to set ourselves up on a good rendezvous here. If we look this way, we're 20 kilometers away, which is really not great for a rendezvous, but it's good enough. We can work with that. We have plenty of fuel, although it is not divided out well between our engines because of the way that this has been set up. That was me being an engineering mistake, but you work with what you got. Let's get like this maybe. Try to get ourselves so that we're headed more or less straight towards our transfer stage. As we get in closer, we're going to have to kill some of our relative velocity so that we can bring ourselves in for a nice docking. So we're going to actually even burn a little bit more towards it to get closer. Maybe get up to about 22 meters a second. That sounds good. Get ourselves ready to slow ourselves down when we get close. There we go. We're a few hundred meters away. That's good enough for us to now get ourselves ready to rendezvous, or to dock. We are rendezvoused. We can see the other spacecraft. We're going to switch to chase cam, which will allow us to keep the camera orientation lined up with our spacecraft. And we can go ahead and turn on the RCS engines. And we want to more or less just move in very nice and slowly towards a docking. We're moving into the dark, which is a bit of a bummer, but on the other side, we do have lights illuminating the docking port on this other spacecraft, so that's good. And as we go, just keep ourselves oriented as best as possible towards him. And we're getting quite close, 114, 100 meters basically. So now, looks like we're close to lined up, so now we just want to be heading straight towards the other spacecraft. And bring ourselves in for a nice, easy docking. Look at that, and those lights are nicely on either side of the docking port, showing us where it is. And just move it right in. We'll do a little bit more time warp, but not too much because we're pretty close. Okay, so we're just going to slow ourselves slightly. Make sure that we're lined up. Everything was looking good. Look at that. It really is. It's just a slight maneuver of our nose. And when we touch, I'm going to turn off the SAS, which will allow mating to occur more easily. See, they're trying. They're kind of dancing around on each other, our docking ports here. And the magnetism should pull us right in for a docking any second now. Any second. And we'll try to cycle the SAS a little bit here. There we go. We are docked. Okay. So now we have to do a few things. One, we're going to find which of these fuel tanks is the empty one. Probably this guy? No. This guy, 114, 114, 133, and 114. Ah, because he's... Okay. So what we're going to go ahead and do here is transfer all this fuel from this stage into the lander. I was hoping we could use that stage for our transfer, but we cannot. So we're good though. We are going to go ahead and ditch him. And now we're going to shut down the engines on the lander, of course. And activate our 2 nuclear engines for our interplanetary transfer. To do that, we're going to just go out to the map view, select Duna as our target, and set ourselves up a maneuver. We're not actually going to burn out to Duna yet. We're going to go ahead and burn like that. We're going to do maybe 2 passes, which will allow us to take more advantage of the Oberth effect depending on our acceleration, because it's better to burn as close as possible to the periapsis. So it's better for us to do this burn, get ourselves out near the orbit of the moon, do another orbit, and then burn again at the periapsis. So that is more or less what we are going to do. And just bring him around until we get to this node. We'll see. My guess is it's going to be a 2 or 3 minute burn. So we'll go ahead and start now. Saying a 4 minute burn, 4 minutes and 15 seconds about. So what we're doing is basically splitting this into 2 4-minute burns instead of 1 8-minute burn, which really can have a huge effect on our, on the efficiency of this flight. So hopefully this all will go well. We're just burning, burning, burning. It doesn't take that much more delta V, actually, to get to Duna than it would to go to the moon. It's really a very similar mission. Many moon rockets can do a Duna mission, especially if you throw a parachute onto the lander. At least to get there. Going back will take more delta V than coming back from the moon. So, and if you have parachutes on the lander, it clearly takes a lot less delta V to land. So there we go, look at that. There is our spacecraft burning its engines. There's the moon behind us. Go do some physics warp here, just get ourselves, make this go faster, because I'm doing this all live commentary. I'm not going to go do any post commentary on this, and we don't want it to take, the video is probably already going to be an hour. I'm probably going to divide it into 2 videos in the end, so we'll see what happens with that. But on this video we're at least going to get through to our injection, so it's going to be this burn and at least another burn, which will bring us out to Duna. And of course, when you're flying to Duna, you want Duna to be about 45 degrees ahead of you in its orbit, which will allow you to basically catch up to Duna, because Kerbin is in a lower orbit than Duna. It is going faster. So when you leave Kerbin, you are actually leaving Kerbin with Kerbin's orbital velocity, and plus whatever orbital velocity you add. So you're better off, the proper way to do it is for planets that are further out from the sun than you are. You want to burn on the night side of the planet first. That's important. So let's just see. Let's get our close encounter. And maybe if I move the point that we burn. No, it's getting bigger now. So the question is, we're going to be behind him. So we're actually a little bit late. So what we're going to do here to counteract that, maybe we'll burn a little bit towards Kerbin here. And there we go. We've set ourselves up. 1 minute and 48 seconds of burn, and we will have a Duna encounter on our ejection. And we should have more than enough fuel. Yeah, we're looking good as far as fuel goes. So just bring ourselves around to the maneuver node. And of course, if you want to know exactly the angle the planets should be at relative to each other, there's the KSP.OLEX.something calculator, Kerbal alarm clock, which I have installed, but I'm not actually using it right now, also has a transfer window calculator built in. Um, but as a general rule, the further out in the solar system something is, the further you want it ahead of you. So Joule, like Duna, you want to be at about 45 degrees ahead of you. Joule, you want to be about 90 degrees ahead of you. Elu is a totally different story because Elu is a little bit, it's different because it's on a very elliptical and inclined orbit. So won't even worry about that. And the inverse is true on the inner planets. So for Eve, you want Eve to be behind you because Eve is going faster. So you want Eve to catch up to you. And the same is true for Moho. Interestingly, Moho orbits so fast around the sun, you get transfer windows all the time for Moho. So, but Moho is probably the hardest planet to get to. Really, there are 3 really, really hard missions in Kerbal Space Program. One is doing an Eve return mission because launching back from Eve is nearly impossible. It has a very, very thick atmosphere and very, very high gravity. So at this point I'm going to get rid of my node, by the way, so we can actually watch in real time what happens with our encounter. Another is Tylo, which Tylo is difficult because, and there we go, as you see we've burned to an encounter. Anyway, Tylo is difficult because it has nearly Kerbin's gravity and no atmosphere. So taking off from Tylo is much easier than taking off from Eve, for example. But Tylo is much harder to land on than Eve because Tylo, which of course is a moon of Joule if you didn't know, the problem there is landing. You need a lot of fuel to land because you can't use parachutes and use the atmosphere to slow you down. And the other hard mission in Kerbal Space Program is going to Moho, which landing on Moho is actually relatively easy. It's like landing on the moon. The problem is getting to Moho takes a ridiculous amount of delta V. Delta V, of course, is your ability to change your speed, which is a way of saying the range of your spacecraft. So it takes a lot of fuel, basically, to get to Moho. And then, when you go to Moho, you are going so fast relative to Moho, it takes a lot of fuel to get yourself into orbit of Moho. So those are the 3 really hard missions in Kerbal Space Program. I have done Tylo and Moho. I have not done Eve. I mean, I've been to Eve. I have never successfully done an Eve return mission. But that is something I'd like to do. I want to, but I probably eventually will maybe do a video on one of those, or maybe even all 3 of those difficult missions in Kerbal Space Program. Not that other missions are necessarily easy. You know, this is all relatively realistic orbital mechanics. Obviously, a patched conic system, which is what's used in this game, is not the most realistic, type of orbital calculations, but it's fairly accurate. What's going on is it's using a 2-body approximation of Newtonian physics, where in real life, of course, you're not in spheres of influence, so to speak. The gravity of every body in the universe affects every other body in the universe. But that would be crazy to deal with. So instead we use what's called a patched conic system, which is what NASA used to calculate their missions, the Apollo missions. So we are definitely, it's close enough, as they say, close enough for government work. So here we go. As we approach Duna's sphere of influence, we're going to do a course correction maneuver to try to bring our orbit in. It's hard to set up a maneuver here because we have the next orbit showing there. So instead, we're just going to experiment a little bit. See, burning retrograde makes our orbit go further out. So we're going to burn prograde. And I want to bring at least our orbit in closer than Ike, which, as you see, is Duna's moon here. And this looks like it's the right way. And at this point, we're coming in south of Duna as well. So now we're going to do some northward burning to get ourselves set up close to the equator of Duna. And now some more prograde to get ourselves further in. This is just quite a bit of tweaking. It's better to do any course corrections before you get into the sphere of influence of whatever body you are traveling to. The reasons are somewhat complicated, but just it's good to know that it's better to do the corrections as early as possible whenever possible. So you see we're going to come into a relatively low Duna flyby, and we are actually, once we get into Duna's sphere of influence, set ourselves up for an aerobraking maneuver. So here we go. We're just going to time warp until we get to Duna's sphere of influence. So for full disclosure, the only two mods I have installed here are Kerbal Alarm Clock, which of course is going to pause this as it did before to let us know we're about to cross over spheres of influence, which is a very useful feature. And Kethane, which we're not really using on this mission, but I do have it installed. I don't actually really use it, I just have installed it. I haven't really experimented with it yet. So as you see, here we are, we're in Duna's sphere of influence. We have a decent amount of fuel left in this spacecraft. We should have more than enough to do what we need to do. But we're going to call it a day for now. And in the next video, we will capture into orbit via aerobraking and bring ourselves into a stable orbit and go into land. In the meantime, I've been Neil. I hope you enjoyed, and see you next time.